Welcome back, Algebra. I'm going to talk about some non-linear inequalities. So this is a linear inequality here, and it's linear inequality because we have a line. Line equals linear. So we know that with linear inequalities, we have three areas that the line divides the coordinate plane into. So we have the area that is greater than the line. This is 1. So y is greater than negative 1/2 x minus 1. That's all the points that if you subbed it in for y and x, that would satisfy and make this a true statement. Then you have the line itself, which is equal to 1/2 x minus 1. So this is all the points that if you subbed in for x and y would make this an equal statement, would make the equal part true. And everything below the line, those are all the points that would make the statement y is less than negative 1/2 x minus 1 a true statement. So those are the three sections that you get with a linear inequality. So let's talk about combining that linear function with something like a parabola, and let's see what kind of areas we get there. So let me clear the page, and then I'm going to give you a example problem to do. All right, here in problem or example problem 114.1, we have a line, which is the green line here, that is y is greater than or equal to 1/2 x minus 4, and we have a parabola that is y is greater than or equal to negative x squared plus 4x minus 1. So we see with our line that it crosses the y-intercept, or the y-intercept where it crosses the y-axis is at negative 4. And we have a positive slope of 1/2. And with the parabola, we have a negative, so it opens downward. And we have a negative 1, which is where it intercepts the y-axis. And everything else is figured out by solving the problem, but it's already given to us in the book, so I'm not going to take the time to solve that just yet. But what we can see from these two equations here, or inequalities, they're not equations, they're inequalities, I gotta correct myself there, is that we are talking about points that are greater than or equal to in both of these inequalities. So that means that everything above both lines, which would be everything in section A. This would be section A, everything here on the outside of those lines. And actually, I'm going to go ahead and just extend this line out, just so we have it all the way to the end of our graph. That's going to make it a lot easier to, I'm just trying to find the slope here. Yeah. So if we just focus on the area, let's just focus on the area within our little section here. I'm going to cross that off, and I'm going to stop this here, and let's come all the way across. So everything within this little section right here, we'll just, where it crosses, we'll let that go on. All right, so this little area here, this is what we're going to worry about. Let me get a different color. Let's use this gray color, and we'll just worry about shading in, oops, wrong place, get a lighter gray here. We'll just shade in everything in this little bit of the graph. We'll just pretend that's all we have is this little square right here. There we go. So that's our graph that we're talking about. Let me get rid of the shading. There we go. All right, so here's what we're going to do. A is going to be considered every bit of this on the outer part above both of the lines here. So you can kind of see that. Area B is going to be considered the part on the inside, right here, of the parabola. That's going to be less than the parabola, but greater than this green line. Now this area here is section C, and that's going to be less than the green line, but greater than the parabola. Now this area over here is also included in C because it too is less than the green line, but greater than the parabola. And then we have section D, which is less than both. It's under the green line and it's on the inside of the parabola. So those are our 4 sections. It's interesting that both of these sections, even though they're separated, they will make the same statement true, being on opposite sides of the parabola. So what we have to do is find a point and test it and see if our assumption is correct. So we're going to choose a point in section A because A is greater than both lines, okay? And that both of these are greater than. So that's the area that makes the sense to test. So we're going to substitute in 0 and 5 into both of these statements and see if this inequality remains true. So 5, let's do the first one, which is going to be 5 is greater than or less than 1/2 times 0 minus 4, because that's what we have here. So 5 is greater than or equal to 0 times that is 0 minus 4. 5 is greater than -4. So that is a true statement. So let's try this one. 5 is our y, so 5 is greater than or equal to a -0 squared plus 4 times 0 minus 1. So 5 is greater than or equal to, a 0 can't be negative, and 0 times 0 is 0. So 0 goes away, plus 4 times 0, that's another 0, it goes away. So we have -1 left over. 5 is indeed greater than -1. So yes, this point makes both of these statements true, so we can assume that all the points in section A will make this statement true. So I'm going to take my highlighter and I am going to color in all of the area as best I can, because I'm not the best colorer in the world because I'm over the age of 5. So this would be the area that you would highlight as your answer, is the area above in section A. Okay? All right, so what we're going to do is we're going to graph some more lines and functions, circles even, and then we'll see what we have. All right, I'm going to clear the page and we're going to do another one. All right, here we are in 114.2, and we have a line and a parabola again. And this time we have a positive parabola, and it opens upward, and the intersection point is +2. We see that here. And the point of axis is on the -2. That's the axis of symmetry, is on the -2 line. So we see it mirrored here at the 2, 1, 2, 1, 2. So that's correct. Now our line is a less than, so it does not have the equal. So it's going to be a dotted line because of that. And it's a negative x, so it is going to be a downward line. So all of that is true. It has a 1/1 because there's no coefficient here. The coefficient is 1. And because it is a -1, it is downward 1/1, which is down 1/1, down 1/1, down 1/1, which is exactly the slope of this line. Okay, and we also see that the intersection point is a positive 1, which is right here. So that's correct as well. So everything is drawn correctly. So now we need to assess where we're going to shade in. So let's pick a point here. Let's look at this and see if we can make sure that our guess is correct. So we're going to say that it's going to be greater than the parabola line. Greater than or equal to the parabola line. And in this case, what is above the parabola line is going to be on the inside, right? Because this is above, this is on top of the parabola. So it's funny how the shape changes based on whether it's a positive or a negative parabola, opening upward or downward. So greater than is going to be on the inside of the parabola and everything above it. Now the line itself is going to be less than the line. So the only area that we have that is above the parabola line and below this line is right in this little section right here. Okay, so let's pick a point in here. Let's pick -2 and 1 right there. So we're going to pick -2 and 1 and check that and make sure that that area makes all the points, makes all the statements here true with that point. And if it does, then we've picked the right spot. So we're going to sub in here. We have 1 is greater than or equal to -2 squared plus 4 times -2 plus 2. I guess I should do that in black because that's what that is, but you'll just have to see that. That's the one I'm doing. 1 is greater than or equal to, let's see, -2 squared is going to be a positive 4. That's going to be -8 plus 2. Positive and positive, that's 6 minus 8, so 1 is greater than a -2. So this one, that is correct. So -2 and 1 makes this one correct. So let's try this one. Let's see if it makes it correct. So 1 is my y. 1 is less than a -2 plus 1. So 1 is less than, negative times negative is positive, so 2 plus 1, 1 is less than 3. So this one is correct also. So that tells me that the points in that area that we have determined do indeed make them true. So I'm going to use a smaller little line, little highlighter here to get all of this nice and shaded. And there we go. So that is the area of our coordinate plane that makes all of the points, or that makes these two statements true. Those are all the points that makes both of those true. All right. So let's see if we have another one. Yes, we have one more. These are kind of fun, so I like doing them. All right, in 114.3, instead of a parabola and a line, we have a circle and a line. And our line is y is greater than or equal to x. So it has the or equal to, so it is a solid line. And there is no plus b. So when there is no plus b, it's actually plus 0. That's what that would be. So that means that your intersection point is 0, 0, which is the origin or the very middle. Okay. So whenever there's not anything here, you can put in plus b or plus 0, or just remember that when there's not a plus b, it's 0, 0. It's at the origin. And we know that when a variable is by itself, it has that invisible 1. So the slope is 1 over 1, and it's positive, so it goes up to the right. So that is all correct for our line. All right, our circle is x squared plus y squared is less than or equal to 16. So when we solve this, we would find that the x and y would be 4. So 4 and 4, 4 and 4, or 4 and 0, 0 and 4, 4 and 0, 0 and -4, and positive 4 and 0. This should have been negative 4 and 0. So it's 4 all the way around, centered on the origin. All right, we know it's centered on the origin because there are no coefficients here that would move it one way or the other. So now we have some areas we have to think about. So if it is above the green line, right, and above the red line, they would both be greater than, right? That would be what we would call our section A, first area. And A would equal greater than, right? Let me put those in the color that we need. So it'd be greater than on the green, and it'd be greater than on the circle. So for section B, it'd be right in here, we would have, see, it's on the inside, so it's less than B. So it would be, the red would be less than, but it's still above the green line. So it would be greater than. I'm sorry, this should be less than right here. Right? Now we have another area, C. And C is going to be less than the red line and also less than the green line because it's below the green line. So that would be less than for both. And then we have another area that's D, and D would equal less than on the green, but it would be greater than on the red because it's outside of the circle. It's greater than the circle. So there we go. Those are our combinations. Let's see which one we have here. On the red, we have less than. So that crosses out this one, and that crosses out this one. And on the green, we have greater than, so that gets rid of this one. So we're looking at something within area B. So let's pick a point in area B. Let's pick, how about right here? Let's pick -2, +2, and sub that in, okay? So we're going to use -2, +2 in area B and see if that works. So let's try it and see. So our y is +2 and our x is -2. So let's do the red one first, the circle first. So that's going to be -2 squared plus 2 squared is less than or equal to 16. -2 squared, remember it's like this, it's in parentheses. So -2 squared, that's going to be a +4, plus a +4, that's going to be 8 is less than or equal to 16, and it is. So that's correct. So now let's try the green one. So that one's pretty easy. Y is +2 is greater than or equal to, and x is -2, and that one is correct as well. So that tells us that, yes, B is the area that we're looking for. So let's take our little shaded shape here, and we'll just color right inside, and we'll get all of the area that is less than the circle, but still greater than the green line. And that is section B. And there we go. And that is our answer to all the points that would make these two statements true. So it's not very difficult. The hard part is making sure you graph the circle and the line in the right spot. And you have to solve to get that first. For the most part, that's going to be given to you in most of your problems, and you just have to tell the right area. So don't struggle too much with that. But that is what we are looking for in lesson 114. And that is all we have, and I will see you all in lesson 115.